Alright, so I'm going to walk through a few examples that were from Chapter 4, Probability, and that's because your test on Chapters 4 and 5 is coming up on Wednesday, so we're going to go back and review this information before I'm expecting to know it on a test, so this gives you a couple days to maybe look over this stuff. Alright, starting with some very easy single event probabilities. These are not intersections or unions, just probability of a singular event happening. So the probability that I roll something less than a 5, so 1, 2, 3, or 4 would be my list of favorable outcomes, so there's 4 of those. 5 and 6 are unfavorable. Now, since the die was 6-sided, there would be 6 total possible outcomes, 4 out of 6. So my answer would be 2/3, or you can also answer with a percent by doing 2/3 multiplied by 100, and that would be 66.7%. Usually I'm going to be talking about percent answers, but if the test is multiple choice, you could see fraction, you could see percent, or I could even see 0.667 with a decimal answer. So you got to be able to figure any of these depending on what they've done with the multiple choices. You might see any of those. Alright, so on example 2, we're going to see what the probability is that we roll a multiple of 3. So between the numbers 1 and 6, the only multiples of 3 are 3 and 6. So the probability of a multiple of 3, there's only 2 favorable outcomes, 3 and 6, out of 6 total possible outcomes. So my probability here would be 1/3. Now, I would also accept 33.3% on this problem, or 0.333. Really, usually I look at percents, but like I said, multiple choice tests, you could get any of the 3 answers. But for the rest of this video, I'm just going to be answering with the percent on all of these. On the last quiz, this was a problem that really gave a lot of people frustration. Is because they're looking for the 4,680 college professors and the 5,140 females to add up to how many people are college professors or female. Well, that's not going to be the case. That's actually going to add up to be a number greater than the number of people that are college professors or female. The simple answer is there's some college professors that are female. So there is an intersection between these two groups. So to do this, you can use a Venn diagram or a two-way table. Either one's appropriate. So I'm just going to make one group my college professors, and my other group the females. And to find the intersection, what I'll do is I'll add up the number of college professors and females, so 4,680, add to that the 5,140. And I'm just going to use a calculator for that. Oh, it didn't recognize my input. 4,680 plus 5,140. And that's going to be 9,820. Now you're going to see that that's more than the 7,315 people that are one or the other. Maybe they're both. So that means that there is an intersection. To figure that intersection out, I'm going to take this 9,820 and subtract away my 7,315 from it. So minus 7,315. So that would leave me with 2,505 female college professors. Now I'd actually be able to find those college professors that are obviously male and the females that weren't college professors. Really, it's kind of nonsense to go forth and do that. It really doesn't matter. I could just do a simple subtraction to get those. But looking at the problem, what's the probability that a person is both a college professor and a female of the 10,500 people that attended this math conference? So now I know my favorable outcome. There's 2,505 favorable outcomes of people that would be both a college professor and a female out of the 10,500 people that were at the conference. Now I can do this division, divided by 10,500, and multiply that by 100 to get my percent, which is 23.8%. Well, 23.9%. I do need to round correctly. So 23.9%. All right, now that's the result on that problem. Lots of people got confused by that on the quiz, so let's try to do a better job than on the test that's coming up. All right, on this problem, they're talking about the pieces of a chess set. They've been placed in a bag, and we're going to find these two probabilities here on parts A and B. I do want to point out, this problem is kind of a little flawed in that since these, if you're talking about drawing these pieces out at random, since these pieces are different shapes and different sizes, to get a truly random event to occur here would actually be very difficult to actually happen. But let's assume that randomness does happen here. All right. So you choose one piece at random, find the probability you would choose a black piece or a queen. Really quick, I'm going to find how many black pieces I have. So I'm going to add these up to be 16 total black pieces. There would be 16 white pieces, making for 32 total pieces within this bag. I could also add up each of my different types. All right. Just to know those marginal frequencies. Remember, marginal frequencies are the values I just wrote down outside of the 32. That was the grand total. These inside that were provided were called joint frequencies. All right, we are going to find the probability that we choose a black piece or a queen. Now, these groups are not mutually exclusive, and what you're going to need to remember is when groups are not mutually exclusive, to find the probability of event A or event B happening, we'll add the two probabilities together, but we'll have to subtract away the intersection. Only when it's disjoint do you not need to make this consideration over here. All right, so the reason why it's not disjoint, by the way, why it's overlapping, is because there is a queen that is a black piece right here, this one queen that's black. So it will get counted in both groups. So now my probability for getting a black piece is 16 out of the 32 pieces. I'm going to add to that the probability of selecting a queen. There's 2 queens out of the 32 pieces. But I do need to subtract away the 1 queen that got counted in both of these groups. The 1 queen that is also a black piece. So I'm going to minus 1 out of the 32. That will always come from a joint frequency there. Now that I've got this set up, I can go ahead and add these together. 16 plus 2 is 18, minus the 1 is 17 out of 32. And I'm actually able to go ahead and type that in. I could have typed it in at the beginning. I just chose to do that first part by hand. And I'm going to get 53.1%. All right, now moving on to part B. Choose a piece at random. You do not replace it, then choose a second piece at random. When you see do not replace, you're going to start thinking dependent events, hopefully. So the probability of event A happening and event B happening is going to equal the probability of event A happening times the probability of event B happening, given that event A has already happened since I'm not replacing the piece. All right, find the probability that we choose a king and then a pawn. So for the first event to happen, a king, there are 2 kings out of the 32 pieces. Times. Now I'm going to consider the probability that I get a pawn if I already got a king on this first draw. Let's look at how many pawns there are. There will still be 16 pawns in there if I got a king on the first draw. 16 has not been impacted. We lost a king, not a pawn. So there are still 16 in the bag. Out of, it is no longer 32. There would be 1 less piece in the bag. So there would only be 31 pieces now. That's how this probability got impacted, and that's how this is a dependent events. So now I'm going to perform this multiplication. I'm just going to use my calculator here. I'm not going to pretend like I'm some genius that can do this, just mentally. So 2 out of 32 times 16 out of 31. And 3.2% is my answer. Remember that you can just simply multiply by 100 to convert it to a percent. Now, if the problem is looking for a fraction answer, don't forget that you could have, once you've calculated it, you could have hit the math key and hit enter on convert to fraction to convert it back to a fraction. So 1 out of 31 is what the fraction answer would have been. So on this problem, part A was something that you should have known. This is similar to a problem that was on the quiz. My mistake for not saying that. So there's 12 people. What's the probability that you, your brother, and your friend are chosen? Now, you're not going to go back into the group to get chosen again, so these are dependent events. For the first event to happen, there would be 3 favorable outcomes out of the 12. Multiply that with. Now, assuming that one of the 3 of you got picked, you're going to have now only 2 favorable outcomes out of 11 remaining people, because one of you did get picked, so there's 1 less favorable outcome out of only 11 people now. And for the third draw, there would now be only 1 person, assuming the first 2 happened, out of now only 10 people remaining. This is related to what I just wrote down a little bit ago, dealing with the chess pieces, that you're considering that the first event happened, and on this last one, we're considering that the first 2 events did happen. So it's really just a chain reaction. Now I'm ready to type these in. 3 out of 12 multiplied with 2 out of 11 multiplied with 1 out of 10. And when I hit enter, I'm going to get a very small value. I will convert that to a fraction really quick. So 1 out of 220. Or, what I could have also done is multiplied the decimal by 100. And I would get 0.5%. Since the 4 would round up there. All right, moving on to part B. This is the problem that I considered a bonus on the quiz because I hadn't really talked about it, but we are now, so it's fair game. On this problem, first person chosen will be the counselor. What's the probability that you are the cook, and so forth? What's the probability you are the cook, your brother's the lifeguard, and your friend is the counselor? So now, for your friend to be the counselor, there's only 1 favorable outcome out of the 12 people for that first event, because your friend needs to be the counselor. The second will be the lifeguard. For your brother to be the lifeguard, there will now be only 1 favorable outcome out of 11 remaining people. And for you to be the cook, there will be only 1 favorable outcome out of the 10 remaining people. So now we're ready to type this in. 1 out of 12 times 1 out of 11 times 1 out of 10. So as a fraction answer, it's very low chances of this happening. This is scientific notation, by the way. I'm going to convert it to a fraction really quick. So 1 out of 1,320. Or back here, even though it's scientific notation, I can still multiply that by 100. That'll just make it E2 instead. And that's going to be 0.08% chance of happening. 0.08% chance of happening out of the 12 people that you 3 would get those specific jobs. Okay, please complete the assignment to the best of your ability. Thank you. And there was the bell.